All right, 25. It gives us these three different measurements and says, hey, can this guy be a triangle? Well, let's look at A. It says sides 2, 6, and 3. So let's start with the first two, 2 and 6. So if I have one side that's 2 and the other 6, well, if we stretched it way out, almost perfectly flat, what would this third side be? That'd be the longest we could make it. It'd be a little bit less than 8. It can't be 8 because that would be 2 and 6 perfectly flat. That has to be bent up a little bit to make about a 179-degree angle. So 8 would be, we can make it close to 8, but not quite 8. What would be the shortest we could make it? Well, if you do 2 and then you bring the 6 straight back almost with like a 1-degree angle, this other side would be about 4. Okay, a little bit more than 4 because, again, 4 would be if you brought it straight back and it's tilted up a little bit. So it's got to be a little bit more than 4. So our measurements can't equal 4 and 8, but it's somewhere between 4 and 8. Well, is 3 between 4 and 8? The answer is no. So we know you can't have one that's 2 and one that's 6 and the other guy be 3 because our measurement has to be between 4 and 8. So A is out. So all we have to do is basically start with these first two, and you'll notice if we simply subtract them to get the smallest and add them to get the largest side, well, does 13 fit between 7 and 13? It equals this 13, but it doesn't fit there, does it? No. So if you had 3 and 10 perfectly flat, that third side would be 13. But again, that wouldn't make a triangle because this side has to be bent up. So B is out. All right, what about 4 and 6? Subtract them 2, add them 10. Does 1 fit between there? No, it doesn't. So C is out. And finally, let's look at this guy, 5 and 7. Subtract them 2, add them 12. Yes, that 3 fits nicely right in there. So D could be a triangle. The rest of them could not.